Hello students, welcome to my channel. In this video, we will learn how we can get the Rydberg equation from Bohr's atomic model. So let's start. First, let us see what is Rydberg equation is. In the 19th century, Swedish physicist J.R. Rydberg found that the wavelengths of photons emitted by changes in the energy level of an electron in a hydrogen can be described by a general expression, and that general expression is 1 by lambda equal to r into 1 by n1 square minus 1 by n2 square, where lambda is the wavelength of the emitted radiation and n2 is the higher orbit and n1 is the lower orbit, and r is called the Rydberg constant and is equal to 109677 centimeter inverse. This is the experimental value of the Rydberg constant. Later we will see the calculated value of the Rydberg constant. Anyway, later, this type of expression was generalized for other hydrogenic system as well, and the expression is rewritten as 1 by lambda equal to nu bar equal to rz square into 1 by n1 square minus 1 by n2 square, where z is the atomic number of the hydrogenic system. Okay, now we will see how we can get this expression from the Bohr's atomic model. In the Bohr's atomic model, it is said that if an electron jumps from an higher orbit, suppose n2, to a lower orbit n1, then the energy difference between the two orbits will be equal to h nu. That is, the energy of the n2 orbit minus energy of the n1 orbit will be equal to h nu. Okay. Now, again we know that energy of an electron in any orbit, nth orbit, it will be minus 2 pi square m into the power 4 z square by n square h square. I have already derived this expression in my some last videos. If you are interested, you can go through that video as well. Anyway, we will replace this en2 and en1 value with this type of expression. Then what will come? H nu equal to minus 2 pi square m to the power 4 z square by n2 square h square, that is for the en2, and this one is for the en1. Okay, now you see here that 2 pi square m to the power 4 z square by h square terms is the common term. So the expression becomes h nu equal to 2 pi square m to the power 4 z square by h square into 1 by n1 square minus 1 by n2 square. Now we can replace the nu value with the c by lambda, because we already know that nu equal to, that is the frequency, equal to c by lambda. C is the velocity of light and lambda is the wavelength, as I said earlier also. So this hc term we will take this in the right hand side. So how it will come now? 1 by lambda equal to 2 pi square m to the power 4 z square by ch cube. Okay, and this term is same as earlier. Okay, now what we will do, we will replace this 2 pi square m to the power 4 by ch cube term as the r. Okay, then expression becomes 1 by lambda equal to nu bar. Nu bar is the wave number, and this is the relation you should remember. 1 by lambda equal to nu bar and nu equal to c by lambda. Means if you want to write a relation between nu and nu bar, it will be nu equal to c into nu bar, because 1 by lambda equal to nu bar. Anyway, then 1 by lambda equal to nu bar equal to rz square 1 by n1 square minus 1 by n2 square, means we have replaced 2 pi square m to the power 4 by ch cube term with the r, and this r is known as the Rydberg constant. And if you put the values of m, e, c and h, this will come as 109737 centimeter inverse in the CGS unit. As I earlier shown the experimental value, it was 109677 centimeter inverse. So this value, calculated value, is very much close to the experimental value. Okay, so this is the famous Rydberg equation, and we have derived it from the Bohr's atomic model. I hope you understood what I have discussed in this video. If you have any question, you can write in the comment box. I'll try to answer those questions. Thank you. Thank you very much for watching my videos.